Carbon and its compounds. Before we get into the details of this chapter, it's essential for us to know a little bit introduction about carbon, because this entire topic is revolving around only one particular element, that is carbon. We need to have certain details about it, like its symbol is C. It is a non-metal. The atomic number for carbon is 6. Its configuration is 2, 4. That is, it has 4 electrons in the outermost shell, valence electrons of 4. It belongs to the 14th group of the periodic table and the second period. So its position in the periodic table is 14th group and second period. It is the first member of this group, 14th group. So the group begins with carbon, that is why it is known as carbon family. The other members of this family are silicon, germanium, tin and lead, in that very order, in the descending manner. So starting from carbon, the family ends at lead. Now, why is there a need to study the compounds of carbon? This is so because all living organisms, be it plants, animals or microorganisms, and a large number of, in fact I should say majority substances, materials, mixtures, fuels, everything that we come across in our day-to-day life does contain carbon in larger or smaller amount. For example, compounds like urea, sugars, fats, oils, dyes, proteins, vitamins, etc. all these are made up of carbon. And we cannot imagine our life without these compounds and other such compounds which contain carbon. So that is why it becomes very essential for us to know the nature of this element, to know the nature of the compounds of this element, and the various other aspects about it. So the compounds of carbon, they are referred to as organic compounds. All the compounds of carbon are not included in this category except for compounds like carbon dioxide, carbon monoxide, carbonates, calcium carbonate, sodium carbonate, and many more, and bicarbonates, sodium bicarbonate, that's also called baking soda, and calcium bicarbonate and others. These are not included in the category of organic compounds. Apart from these, except these, all other compounds of carbon are referred to as organic compounds. Now the term organic compounds itself, it explains, it means something related to organism. Organisms include all animals, plants and microorganisms. So all the compounds which are obtained from living beings, which are obtained from organisms, are categorized as organic compounds. And all these organic compounds contain carbon as the essential component. So we can define in a very simple way, we can define organic compounds as the compounds which are directly or indirectly obtained or isolated from living beings or organisms are called organic compounds. And the branch of chemistry which deals with the study of these compounds is known as, of course, organic chemistry. If you don't know, then there are 3 branches of chemistry: inorganic, organic and physical chemistry. So when we are talking about organic chemistry, it is all about the study of carbon and its compounds. So you can just imagine the number of compounds carbon would be forming in nature. There are millions and millions of compounds, and they are so large a number that we had to separate them out as a separate branch of chemistry, which was named as organic chemistry. Now, before we get into the details of organic chemistry and organic compounds, let's take a look into the bonding in carbon. Because whenever we are talking about compounds, definitely compounds are formed by bonding between atoms. So, bonding in carbon. Most carbon compounds are poor conductors of electricity. The boiling and melting points of carbon compounds are low. Forces of attraction between these molecules are not very strong. As these compounds are largely non-conductors of electricity, hence the bonding in these compounds does not give rise to any ions. You've studied in metals and non-metals that there's a type of bond called ionic bond. That ionic bond is not supposed to be present in the compounds of carbon because of the factors that I've mentioned right now. They are poor conductors of electricity, their melting and boiling points are low, and many more reasons are there, by which we can say that ions are not present or they are not formed in the compounds of carbon. But the reactivity of element is explained as their tendency to attain a completely filled outer shell, that is to attain noble gas configuration, and every element tries to attain noble gas configuration by definitely forming a bond, right? So element which form ionic compounds, they achieve this noble gas configuration by either gaining or losing electrons from the outermost shell. But in case of carbon, I've already mentioned the configuration of carbon, that is 2, 4. It has 4 electrons in its outermost shell, and in order to complete its octet, it needs 4 more electrons. Either it can gain 4 electrons, so its configuration will become 2, 8 and its octet will be complete. The other way around is it can lose these 4 valence electrons and its configuration will become 2, and in this case again it will acquire the configuration of helium, which is a stable configuration, and it will complete its duplet. But it neither gains nor loses 4 electrons, because if it were to gain or lose electrons, then some complications, some difficult situations would arise, like it would gain 4 electrons. Suppose let's consider the first case, that let's say carbon is gaining 4 electrons. So if carbon is gaining 4 electrons, it will convert into C4 minus ion, anion, right? But it would be difficult for the nucleus with 6 protons to hold on to 10 electrons, and that is why the C4 negative anion would not be stable, because addition is only of 4 electrons. 4 electrons are being added to the valence shell. So the configuration will become 2, 8. It will be a stable configuration. But the nucleus of carbon still contains 6 protons in it. There is no addition of protons during this process. So total number of electrons will become 10, but total number of protons will still remain to be 6, and it is very, very, very difficult for 6 protons to hold on to 10 electrons, and that is why this anion will not exist. It will be unstable. Let's take on the other case of carbon, in which it is losing 4 electrons. In that case, it will convert into C4 plus cation. But it would require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons in its nucleus, holding on to just 2 electrons. Now here the case is reversed. The number of protons are comparatively larger as compared in case of C4 plus in comparison to the electrons. So C4 plus will not be formed because of the energy barrier. All the 4 electrons will not come at once or simultaneously inside the atom. Like carbon will gain, first it will gain 1 electron, then it will convert into, sorry, in this case, I'm sorry, it is losing electrons, right? So it will lose electron, it will convert into C plus, it will give out electron. right? And again this C plus will lose electron. Now electron is negatively charged and carbon has become a positive cation. The force of attraction will increase in this case, and now more energy will be required to remove the second electron as compared to the first one. Even if it gets energy and it goes out of the atom, and this carbon will convert into C2 plus. Again the third electron has to be removed from this cation with larger charge. Again more and more amount of energy will be required. So ultimately the C4 plus will not be formed because of the energy barrier. So what type of bonding occurs in carbon compounds? Because it cannot gain 4 electrons, it cannot lose electrons. So the only way out is it will overcome this problem by sharing its valence electrons with the other atoms of carbon or with other atoms of the other elements, right? So in carbon compounds, bond is formed by sharing of electrons. And whenever we talk about sharing of electrons, mutual sharing or equal sharing of electrons, the bond formed is called covalent bond. So the type of bonding in carbon is covalent bonding. The shared electrons belong to the outer shell of both the atoms and lead to both atoms attaining the noble gas configuration, maybe duplet or maybe octet. Before we take some examples of carbon compounds, let's take some simple molecules which are formed by sharing of valence electrons. So we are taking some examples of simple molecules like hydrogen. Hydrogen molecule. This is the simplest molecule formed by sharing of electrons. The atomic number of hydrogen is 1. Its configuration is 1. It has only one electron in its outermost shell, that is the K shell. It requires only one more electron to complete the K shell because the capacity of K shell is of 2 according to the formula 2n square, where n is the shell number. Here we are referring to the first shell, so this will become 2 into 1 square, that is 2. So the maximum number of electrons that can be accommodated in K shell is 2. So 1 is already present in hydrogen. It requires only 1 electron to complete its duplet. So when two hydrogen atoms approach each other, the single electron of both the atoms form a shared pair, and this may be represented as, this is one hydrogen atom, it has 1 electron, and it is approaching another hydrogen atom which has 1 electron. I am representing that 1 electron by this orange dot. Okay, then the bond will be formed, and the bond will be formed between the two hydrogen atoms. This is one, this is the other electron. This hydrogen, its duplet is complete, it will be stable, and because this is equal sharing, mutual sharing, the other hydrogen atom will also share 1 electron and its duplet will be complete. So in this case the bond will be formed by sharing of a pair of electrons, and we can also represent it like hydrogen bonded with hydrogen. This bond is represented by a dash. When we are making a single dash between atoms, this shows that there is a sharing of a pair of electrons, that is a single covalent bond is formed. Now this notation of dot, or it can be cross also, that was proposed by G.N. Lewis, and it is known as Lewis representation or Lewis structure, where the electrons in the valence shell of the atom are represented by dots and crosses. Let's take another example. This time we'll take an example of chlorine molecule, Cl2. Chlorine, its symbol is Cl, atomic number 17, its configuration is 287. It has 7 valence electrons. In order to complete its octet, it requires 1 more electron, right? So this is one chlorine atom, it has 1, 2, 3, 4, 5, 6 and 7 valence electrons. Likewise, there is another chlorine atom, and this has 1, 2, 3, 4, 5, 6 and 7 valence electrons. Both need 1 electron, right? So they'll share. This chlorine has 7 electrons already. It will share 1 electron of the other chlorine atom and its octet will be complete. Likewise, the other chlorine atom has 7 electrons already. It will share 1 electron of the other atom and its octet will also be complete. So again we can represent it chlorine bonded with chlorine atom, making a chlorine molecule Cl2. So these were the examples of some molecules of elements which have covalent bonding in them. Let's take an example of a compound with covalent bonding, like hydrogen chloride. This is hydrogen with its 1 valence electron, and this is chlorine with 7 valence electrons. Hydrogen has 1, it shares 1 electron of chlorine, it will complete its duplet. And chlorine has 7 valence electrons, it will share 1 electron from hydrogen, it will complete its octet. And we can represent this molecule as this. So it will form HCl molecule. Similarly, we can take another example of water or maybe methane or anything else. There are a number of molecules which have covalent bonding in them. Because we are talking about carbon compounds, let's take one example of a compound of carbon. Like I've mentioned it, methane. For example, we'll take methane. Its formula is CH4. Let's see how it is formed. There is 1 atom of carbon. So this is 1 atom of carbon. It has 4 valence electrons. There are 4 atoms of hydrogen, each having 1 valence electron, right? Every hydrogen atom will complete its duplet and it will get stable by acquiring helium electronic configuration, and carbon will complete its octet. It has 4 electrons already. It will take 4 electrons from the 4 hydrogen atoms and it will complete its octet. So this can be very easily represented as CH4. Although this is not the exact or the correct structure of methane, it is only a simple representation which you'll find in different books. Now coming on to the different kinds of covalent bonds. The different kinds of covalent bonds. Electron pairs shared between 2 atoms result in the formation of a covalent bond, and this shared pair is also known as the bonding pair of electron. So on the basis of how many pairs of electrons are being shared between the 2 atoms, we can categorize covalent bonds as single covalent bond, where of course 1 pair of electron is shared between the 2 atoms and it is represented by a single dash. The second category is double covalent bonding, where 2 pairs of electrons are shared and this is represented by 2 dash. And the third category is triple covalent bond, where 3 pairs of electrons are shared and that is represented by 3 dash. We can take one example each of single, double and triple covalent bond. Single covalent bond, we've already seen the examples of hydrogen molecule, chlorine molecule, hydrogen chloride compound and methane also, right? So we'll take an example of double covalent bond. Double covalent bond, for example, oxygen molecule, whose formula is O2. Oxygen atomic number is 8, configuration is 2 6. It has 6 valence electrons. To complete its octet, it requires 2 more electrons. So it will form bond with another oxygen atom. This is one oxygen atom. It has 6 valence electrons, and this is another oxygen atom. It also has 6 valence electrons. So this atom will become stable by sharing 2 electrons. Similarly, the other oxygen atom will become stable by this way. So because there are 2 pairs of electrons being shared, we'll say double covalent bond is being formed between the 2 oxygen atoms, which can be represented as this. Similarly, an example of triple covalent bond is nitrogen molecule, whose formula is N2. Nitrogen atom, symbol N, atomic number 7, configuration 2 5. It has 5 valence electrons and it requires 3 more electrons to complete its octet. So this is one nitrogen atom with its 5 valence electrons. This is another nitrogen atom with 5 valence electrons, and each will become stable by forming covalent bond, which can be represented as. Now let's see, after the examples, let's see the characteristic properties of covalent compounds. Properties of covalent compounds. The important characteristic properties of covalent compounds are: first, the constituent particles. Constituent particle refers to the type of particles that are present in the covalent compounds. The covalent compounds consist of molecules. They do not have ions. This is the difference between the constituent particles of covalent compounds and ionic compounds. Here molecules are present. For example, if we talk about water, it has water molecules, H2O. If we talk about methane, it has many methane molecules, CH4. Hydrogen chloride has many molecules of HCl. Then the physical state of covalent compounds. Weak van der Waals forces are present between the molecules of covalent compounds, and so covalent compounds they occur in all the 3 states: solid, gaseous, liquid, at normal temperature and pressure. For example, silica, SiO2, is a solid. Sugar, C12H22O11, it's also solid. Water, of course, liquid, and methane is a gas. So covalent compounds, they occur in all the 3 states at normal temperature and pressure: solids, liquids as well as gas. So the next property of covalent compounds is crystal structure. This property will be applicable only to the covalent compounds which are solid in physical state. And covalent compounds exhibit both crystalline and non-crystalline or amorphous structures. Coming on to the next property, melting and boiling points. Because here weak van der Waals forces are present, melting and boiling points of covalent compounds are low. Energy required to break the crystals is less because the forces of attraction are very low. Electrical conductivity. Now, because the constituent particles are molecules, there are no free electrons or ions, free ions in the covalent compounds, and that is why they are non-conductors of electricity. Solubility. Due to the non-polar nature of covalent compounds, they are soluble in non-polar solvents like CCl4, benzene, ether, etc. And they are insoluble in polar solvents like water. Although these properties that are mentioned here are general properties, mostly applied, but it's not so that there are no exceptions to it. For example, sugar or glucose, they are covalent compounds, still they are soluble in water, right? So there can be certain examples or some covalent compounds which are showing properties a bit different from the properties which I've mentioned here. So these are the general properties, most common properties, and there can be some examples which are not following these.